Welcome to the May 2016 Deis community meeting. What do we have in store today? Well, to start, we're going to be talking about the V1 LTS line. After that, we're going to move on to getting a status update on Deis workflow. And lastly, we're going to share the latest on the Helm project and take a bit of a deep dive into the new approach we're taking, which is something I'm personally very, very excited about. Before we get into all that, though, I'm actually really happy to report that the release schedule we outlined at the last community meeting seems to be working nicely. If you're watching the project, you can probably tell the Deis core team is operating at a really nice clip right now. And I just want to call it a big thank you to Seth Goings, our new VP of Engineering, for leading that effort and getting that team whipped again into shape. So that's been great. Also, really thrilled to see how much activity is happening now in the Deis community Slack, both from our V1 users as well as folks who are kicking the tires on workflow and the new Kubernetes stack. It's great to see everyone being so helpful. I noticed a lot of positive attitudes in that channel. Seems like we got a really great community. That's kind of the good news. The bad news is Slack ended up being a little more popular than we had planned. We're aware of the challenges that some of you have been reporting regarding the user limit, which prevents new signups. We are working on a solution to that now. In the meantime, though, if you haven't joined the community Slack, you might want to do yourself a favor and now, before we hit the limit again, point your browser to slack.deis.io and get one of those accounts while we still have them. So last thing, if you're interested in presenting something at a future Deis community meeting, something simple like a demo of your environment, hit us up on the community Slack. We'd love to learn more about what the community's up to, and I'm sure everyone on this call would appreciate some sort of demo. So that's it for me. With that, I'm going to kick it over to Matt Boersma to talk about the V1 LTS line. Matt.
Hey everybody, can you hear me okay? Cool. Yeah, I don't have a lot to mention. As you know, we had the Deis version 1 LTS release just about a month ago. We have a 1.13.1 patch queued up right now that we're going to release tomorrow morning. Basically just bumped CoreOS a couple times to address some security issues, revved all the build packs so that they're current, and they're also the same as what we've got in Deis workflow, just to make life easier for us. Also, is Josh on this call? Josh Mize, I want to thank you for fixing that stupid thing we were doing at that CD. That's great that got in there. And yeah, so that's most of the content that went in. I see there's a couple issues that have come up in the last couple days, and I'm going to be looking at those and seeing if we can fix them for this patch. If not, this is our LTS release, so we're going to keep patching it as needed. And then I just wanted to see if anybody had any questions about that, or if there's a particular bug anybody's looking at in Deis version 1 that we should make sure to address for this release that we might have missed. You could either speak up now or else go open an issue on Deis. But if there isn't anything else, then I'm not sure who's next, so I'll give it back to Gabe.
Great, and I'm just going to hand it over now to Jason Hansen, our chief architect, to give an update on where we're at with workflow.
Hey everyone, wanted to briefly cover what we shipped in beta 3, just from a feature highlight standpoint, and then give you a little color on what we're doing for beta 4. First change out of the gate, for beta 3, we're now using secrets to store the builder SSH key. So when the builder restarts, you no longer have to deal with blasting your authorized or your known hosts file. One point of note, it does require you to upgrade to Helm version 060 or Helm Classic, and we'll talk about that because that supports the SSH key generation. The other big thing that landed in beta 3 is private registry support on a per application basis. So you could specify that in the app, specify the Docker registry credentials in the app via new CLI commands, Deis registry :set, username equals and password equals. That will work for any Docker registry that does standard sort of Docker auth out of the box. So Docker Hub, Quay.io, and any copy distribution that you're using. We will be making this a little bit better post-stable for folks who are using cloud-native Docker registries like ECR and GCR. There are some nuances around temporary credentials and authentication that we're going to need to address a little bit differently. The other thing to note with that is that we will pull the image down into the Deis workflow managed registry on cluster, and then deploy the application. The RC will reference the image there, so just a point of note. The last change allows you to modify the period that we wait for pod termination. By default, controller is pretty conservative. I think we wait 30 seconds before moving on to the next pod termination. You can now tweak this via a very long environment variable, which I will not try to recite. That has the effect of speeding up deploys because as soon as the pod transitions into the terminating state, we can then move on rather than waiting for that thing to fully be torn down. Across the board, there's a bunch of bug fixes up and down the component stack. So I'll link you to a gist of the aggregated release notes across all the bits and the pieces. So that's kind of the high-level overview of Beta 3. A lot more changes in that thing that I just linked. For Beta 4, which is slated for release May 11th, so next Wednesday, there are really sort of a few areas of focus. One is this Helm to Helm Classic transition and what that means for the project. And we'll be talking a little bit about what we're doing with Helm, the Kubernetes / Helm stuff. But we're going to need to rename the command. It'll be Helm C, and we'll call it Helm Classic. That's what you'll use to interface with Deis workflow until Kubernetes Helm gets its feet under it. The other things we're focusing on for Beta 4 are release process cleanups and then some version publishing cleanups, which should allow you to more easily track our releases upstream. And then we're going to be merging some of the monitoring work that we've had waiting in the wings. Last but not least, for Beta 4, we're going to be addressing the upgrade story for Deis workflow. So we should ship with upgraded instructions for in-place updates. Yay. Our eventual goal is to have Kubernetes Helm do the upgrade dance for you. But we know that a full cluster teardown and stand-up is not the most amazing workflow. So we'll throw you a bone there. That's pretty much it for Beta 4. So far, everything's on track. The release schedule, the 2-week cadence, RC1 is set for Wednesday, May 25th. And then stable 2.0 is set for June 8th. So I'm sure we'll be tweeting at everyone and blog posting as we make progress. So keep your ear to the rail there. And that's pretty much all I've got. Any questions? Cool. Back to you, Gabe.
Cool. So just to set this up a little bit before we have Butcher jump in. For those of you who've been watching, obviously, we released this tool called Helm, which is a manifest and sort of package management system for Kubernetes. Helm became extremely popular, and we now currently use it to stand up workflow. And so those of you who've messed around with workflow, have seen kind of the Helm command and kind of what it does. It turned out that Helm was a lot more popular than we were, I think any of us were expecting. And as part of the transition of Kubernetes into the Cloud Native Computing Foundation, Helm actually, that project also went into the CNCF under the github.com/Kubernetes/Helm repo. However, as we've been working with the project, we had some changes in direction, and to talk about exactly what that means from the standpoint of the Helm project, as well as what it means for workflow, I'd like to hand it over to Matt Butcher.
Hey guys, I put together, can someone enable screen sharing for me so I can put this slide deck up here?
You should be able to.
All right, yes I can. I like slides. So I'm going to talk through a little bit about the direction we're taking with the new Kubernetes Helm project. Super excited about it. It's fun to watch a tool get broad adoption and then have the Kubernetes org itself say, hey, we'd like to be part of this. So I'm going to tell you about what's going on and how we're trying to do things. In January, Google approached us and said, hey, we really like what's going on with Helm. Can we sit down? We've been working on this tool called Deployment Manager. We think that we might be able to combine efforts and make something cool. And so we sat down with them and began working with them to sort of merge the server-side Deployment Manager and the client-side Helm product and build something better. So why redo it in the first place? Well, one of the limitations we hit with Helm, which we're calling Helm Classic, right? GitHub/Helm/Helm is Helm Classic. The limitation that we discovered is that in our zeal to make it very homebrew-like, we didn't have an in-cluster component that could help manage something. So if you and I are working together on a project and I push the project up on a Friday afternoon and then bail and it dies, you don't have access to the environment that I set up. So you can't quickly go in there and fix it. You have to sort of recreate my environment first and then try and fix it. That wasn't a terribly good user story, particularly not when we're used to working as operations folks as part of a team. So we recognized that as a limitation and something we wanted to correct. Google came to us and said, well, we've been working on this deployment manager thing. We built a thing for Google Cloud Services called Deployment Manager, worked well in that environment. We're trying to translate that same kind of feel into the Kubernetes world. And so we started looking at what they built and what we built. And Deployment Manager was a good platform for managing things once they were in the cluster, but it didn't have that same package manager feel that we were shooting for with Helm. So together we tried to pool our resources and come up with a sort of shared vision that would build us a package manager feeling tool that still had that in-cluster management aspect to it. And so that's what we've been working on doing. We started on this in January. We went down one path, which was to start with Deployment Manager and sort of backport that, or I don't know, backport's probably the wrong word, to try and sort of make Deployment Manager into what we wanted. It didn't work out so well. We just didn't ever quite break free from some of the assumptions that Deployment Manager was making. And so at some point we paused and said, are we at all on the right track for building the kind of tool that we set out to build? And we didn't really feel like we were. So we rebuilt some of the core in-cluster code and now are sprinting ahead on that. So if you've been following the Kubernetes/Helm repo, you've noticed that at some point a few weeks ago, we had a very massive rebase that basically wiped out a ton of old code and dropped in a fresh new code base. That's the one we're planning on going forward with. And that one is designed to have that package manager feel in the front end, but work well for collaborative DevOps and operations in the back end. So we basically have reset our goal and said, okay, we want a tool that streamlines the installing and management of Kubernetes applications. That's exactly what we're going to build. We came up with kind of a set of core principles that would guide us toward building this, and there are 5 of them. I'm going to walk through them first rather quickly. The first one is user experience should come first. We were going down a path where it was turning into an experts-only kind of system, but we decided we wanted to build something where, you know, the commands are short, configuration is easy, the installation is dead simple, collaboration should be easy and fairly intuitive, and we wanted to avoid situations that required people to really dive in and understand the entire ins and outs of this system before they could make use of it. Second principle was we sort of fell back on our 12-factor roots to this idea that build plus config equals release. And we said, that's kind of the feel we're going for here, right? We want it to be the case that you take a package solution, you know, your quote unquote source code, the chart, and you add your configuration values to say, this is how I want this chart to run in my context. And then it gets dropped into your cluster in the form of a release. Okay, so a chart, as you may be familiar with if you've used Helm Classic, the chart is like the expert-built recipe for installing an application. And you can think of the artifact, you know, when you're installing a package into an operating system, you install the binary and then you drop a bunch of config in Etsy, right? And you've got these Etsy config files. The values files that we use in the charts and that you can overlay on top of a chart, those serve as like the Etsy configuration files. So we've got, the build plus the configuration. It gets pushed up into Helm's server-side component, and the output of that is Kubernetes starts up your resources, and that becomes your release. So your little bundle of resources that are started in Kubernetes collectively we refer to as a release. And a release is a thing whose life cycle we can manage. Okay, so those are the three. When we boiled it down to three concepts, we thought this should be easy for users to grasp, for chart developers to grasp, for us as Deis trying to build this thing to grasp, and we think that's the right step forward. Third principle, don't duplicate state data. This is a lesson we all learned the hard way, right? We were going down this path where, the client knew some things about it, the server knew other things about it, and Kubernetes knew yet a third set of things. And so we were starting to duplicate state all the way through the environment. When we stepped back and re-architected, we said a fundamental principle to doing this right is to say Kubernetes is the authority on what's running and what its current running state is. But we need to be able to track the release object as a higher order object and say the release is this thing, but it's tied to all these resources in Kubernetes, but we're going to ask Kubernetes to tell us about it instead of trying to store various state and get into these cases where we have to reconcile state between two storage engines. Principle 4 is one of my favorites. Elegance trumps fully featured. Okay, so elegance is this idea that you want to capture the essence of the problem, address the essence of the problem, and that is your goal, right? Fully, we were heading down toward paths where we said, okay, what about this crazy edge case that we've never ever seen before, but somebody might have? And we were starting to engineer out into the extremities. And the result of that was that the core system was getting very difficult to use. At one point, I realized that one of our core commands was at least 80 characters long when you typed out the entire command line. And I'm like, oh, people are not going to love us for building tools like that. So our principle basically boils down to these four things, right? If it's not necessary for today's requirement, we're not going to implement it. We're going to focus on covering your core use cases first, and then we're going to work our way from solving the core use cases well out into some of the edge cases and extremities, right? We are not setting theoretical completeness as a design goal. We're setting usability as the design goal. In all cases, the sort of theoretical aspect of the system is really there only to support the fact that you as developers, as DevOps, and as operators need to actually use this tool to get stuff done. That was actually our driving force for coming up with that three-part config plus application equal, falling back on that. We said this is the kind of theory that makes sense to us, not having 9 different layers of abstraction. And finally, and this part's for you, right? We committed again to saying we're going to ask people to tell us how they're using it instead of coming down with fairly heavy-handed dictations about this is how you will use our system. And so we've made a renewed effort. Many of you have probably had us reach out to you and say, hey, tell us how you're using this. Tell us how you're building charts. Because it's important to us to kind of learn how the system is being used today and then rebuild it to do that. So that was another aspect of that reset. The last principle is the principle of least surprise, okay? We were getting to this point where we had invented an elaborate vocabulary to describe things, and we had started to look at ourselves as building this kind of snowflake system unique unto itself, never before seen on the planet. And we went, wait a minute. Package management is a well-trodden path. Configuration management is a well-trodden path, and so is infrastructure management. So we're going to recommit to trying to make something that is not surprising to you. When we say you run Helm install, you should understand, okay, that means I'm taking this thing and I'm installing it on the cluster. You don't need to know a new vocabulary of things. You don't need a very sophisticated tool set. And so we've recommitted to this idea that what we build should be intuitive to you. If you start looking at Helm and it doesn't make sense to you, we've failed on that and you should file an issue. And we will try and fix it because we're committing to not being a surprising, unique snowflake of a platform. Okay, so those were the principles. When we applied these and sat down and started building something, what we came up with was a very simple in-cluster tool that we're calling Tiller. Get it? Because you got the helm as the steering wheel and the tiller is the thing that connects the steering wheel to the rudder in a boat. Yeah, we're clever like that. Yeah. So helm is the client, just like it was before. Tiller is the in-cluster server component. And then tiller communicates a lot with Kubernetes. And we're using Kubernetes, first of all, as the deployment platform, what we're deploying into, but also we're trying to leverage it to store information. We're trying to use it with to do label queries to find things and really really take a deeper perspective and not try and implement another layer on top of Kubernetes with its own abstractions and databases and things, but to say we're part of the Kubernetes experience. So when it comes down to it, the high level architecture looks like this. You got a client. The client's job is to manage the user's interaction with the charts, right? I want to use this chart. I want to install this chart. I want to build or create this chart. And then its secondary job is to take that information and communicate the necessary parts of that upstream to the server. We opted to use gRPC instead of JSON REST because we think that's where the momentum in the Kubernetes project is. And plus it gives us a lot of strong typing and built-in error control. And we're really enjoying using it, actually. It's been a great experience. I'll tell you about it some other day. The tiller server's job is to receive data from the client, particularly charts, figure out how to render that stuff and prepare it, and then load it up into Kubernetes, and then kind of track to make sure that the thing the user asked for can be identified in the Kubernetes cluster. So that's that idea of the release, right? I push up my Nginx chart, it adds all my configuration and renders it, prepares it, pushes it into Kubernetes, and then the client can say to tiller, hey, I want to know about the status of that release. Oh, well, here's the status of that release. I pushed it into Kubernetes. Kubernetes says it's in this state. Okay, and then Kubernetes is responsible for all the things Kubernetes already does excellently, right? I'm going to skip over this one, but I did want to include sort of a ladder diagram to sort of show the idea of how it would interact. Helm can fetch charts from a repository that has version charts in it. Those get pushed to tiller. Tiller and Kubernetes do a lot of chit chat, and then tiller comes back and says, okay, good, you're good to go. Okay, and that's kind of the workflow we were shooting for. All right, to sort of wrap up, I wanted to talk through the 8 key features that we think are big improvements over where we were when we released the original version of Helm Classic and where DM was when we underwent this merger and everything. We've got one server, one client. This was a big deal to us. We're shooting for elegance. We're shooting for simplicity. Helm Classic had one client, 0 servers. A deployment manager had 4 servers and a client. We tried to strike a balance and hit out with one client, one server, and then use Kubernetes as much as possible to get stuff done for us so we weren't reinventing things. Again, we switched from REST and JSON into gRPC because Kubernetes is doing it, because wire compression is great, because we get a lot of broad support for different languages, so you can build your own tooling that talks directly to the tiller server instead of having to use only the Helm client. And we had a drastic reduction in our code weight by switching to this. And Go and gRPC are a good pairing because Go's strongly typed, opinionated language and gRPC's strong typing work well together. Chart dependencies. We have been trying to solve this dependency problem this way and that way over and over again. The Helm Classic one tried to resolve dependencies at install time with strong semantic versioning. We ran into versioning issues. We ran into cases where if GitHub was down or unavailable, people couldn't install things correctly. We had a number of heartache of different kinds of heartache with that. When we tried to implement everything in DM, we actually made the situation a little bit worse. DM was also GitHub backed, but when we tried to break away from GitHub, we made some poor decisions and ended up being more network dependent. So with Tiller, we tried to handle dependencies at chart development time. So the chart developer is responsible for managing all the dependencies, getting them all packaged in one big bundle. And by the time you as the operator get to running Helm install, you don't have to cross your fingers and hope that the right repos are up and that the network is stable and all of that. Everything gets installed. It's immutable. What you got on the package on the client side is exactly what's going to get deployed on the server side. It's deterministic and repeatable, which is, of course, a good thing for all of us. And then it allowed us to do some kind of sophisticated stuff where we could say, all right, at install time, the chart says I can use either Postgres or MySQL. I can just toggle a value in the values flag, and it'll say in the values file, and it'll choose MySQL. So it gave us a really strong balance of determinism, immutability, and configurability that we think will translate to a really good ops and DevOps experience for people, which is what we were shooting for. Sandbox template engine, we now include a first-class template engine. It's the Go template engine, augmented with about 50-some template methods and some and a pretty robust way of supplying values into the template. We had tried a couple other approaches. We got way down the rabbit hole trying to do this with Python Jinja before realizing that we were just in a security morass. So we backed up, and now we've decided on Go, which is a nice sandbox template engine that won't allow, various kinds of break out of the sandbox exploits. Charts are managed now by the client. So we kept this part of Helm. We went down this path where the client would request that the server manage a chart on its behalf, and it turned into a very complex experience. So we backed up and went back to the Helm Classic route of saying the Helm client is responsible for saying what charts it wants out of which repos, and the client is the sole sort of source of network negotiation, basically, or repository negotiation. So the client says, these are the repositories I trust. I download my charts here. I get everything configured. I push it up into the cluster, rather than saying, here are the charts I'd like the cluster, the repositories the cluster should contact and configure. We got also less opinionated about chart source. Helm Classic only supported GitHub. Deployment Manager only supported GitHub. When we put them together, we only supported Google Cloud Storage, which was a change in a different direction, but not satisfactory. Tiller and Helm will now support pretty much anything that can speak simple HTTP, HTTPS as a chart repository format. We basically looked at how Debian and Red Hat have been doing this kind of stuff for years and said, you know what, they were onto something. So we're following that model instead of wedding ourselves to only one platform. Getting close to the end here. This one I've talked about several times. We want to use Kubernetes as much as possible. So we store our data in Kubernetes as config maps. We use the Kubernetes API directly. We don't try and shell out to stuff anymore. We're using Kubernetes labels as sort of the way to identify what a release is and which things are components of a release. And we're also working really hard to get to the point where Tiller can run as a replicated service with more than one instance, because it doesn't have to handle all of the internal state tracking. It can rely on Kubernetes to do the state tracking, and Kubernetes already does an excellent job of that. Finally, repeatedly, since our very first release of Helm Classic, people have said, we need strong versioning. And we've said, yes, we understand we can't figure out how to do it well. We think we've finally gotten to the point where we understand how to do it well. And part of that is by embedding dependencies inside of the master chart that we talked about a little while ago. But another part is switching to consistent semver stored in repeatably gettable URLs and not in GitHub, where you might get different things each time. And we've tried to streamline the process of development, so you'll be able to spin up a dev server to test your own chart development process by using Helm Serve. Actually, we're going very strongly in the direction of building end-to-end testing for charts, so that you can test the whole platform start to finish that way. And then there's some random other tests changes we made. The EDE testing I just mentioned. We're going to try and stay very close to the edge of Kubernetes support. Basically, all we're committing to having to do is pull a new version of the Kubernetes API and rebuild everything. It seems to be going really well right now. We're looking into using Ubuntu Thin, which is in the Kubernetes extension repo as an alternative for Alpine, which gets us a little bit past some of the Alpine issues with the muscle implementation of libc and the famous DNS resolution bug and stuff like that. Okay, so that's where we're going. We're super excited about it because we feel right now like we're on really solid footing. We're making progress very rapidly. If you go hit up the Kubernetes Helm repo today, you can actually build stuff and use it and kind of kick the tires. It's not great yet. There are still several pieces, major pieces that are missing. As soon as we get the major pieces in, we're going to cut an alpha release. That's all good. But what about the current GitHub/Helm/Helm? Here's the rough plan. We are calling that thing Helm Classic now. So the new one is Helm, the old one, or the new one is Kubernetes Helm, the old one is Helm Classic. The plan for Helm Classic is that the repo is going to get renamed from Helm/Helm to Helm/Helm-Classic, and that's simply to help us sort of differentiate so that people get a little less confused between the two. And so that we all have sort of a common nomenclature so that you can say, I'm working on Helm Classic, or I'm working on Kubernetes Helm, instead of saying, I'm working on Helm. Which one? Well, I don't know. Which one's here? Oh, that's this. So basically the nomenclature name changes to help with that. We changed the command on Helm Classic, as Jason mentioned before, from Helm to Helm C, so that for those of you who will be in transitional periods, you can still run both versions side by side. We are committing to keeping Helm Classic in maintenance mode until Kubernetes Helm is a complete and stable replacement for it. So the Deis team has actually shouldered the additional burden of keeping Helm Classic up to date, while the 4 of us that are active Helm developers can focus on getting Kubernetes Helm running. So we feel like we have solid development teams behind both efforts right now, though the Helm Classic one is in quote unquote maintenance mode, right? We're trying to keep it stable, we're trying to keep it familiar, and not add a whole bunch of new features to that, while at the same time the Kubernetes Helm team is working on implementing features like crazy. Yeah, that pretty much wraps it up for me. Please feel free to jump in. You guys have already, many of you I know have already participated in the Helm/Helm issue queue. That's a great place to keep working on Helm Classic. Take a look at the Kubernetes Helm project, see what we're doing. The docs directory there talks about the design and has a getting started guide and some stuff like that. I'd love to see you guys drop in and say, this is what we're interested in. This is what we would really like to see out of this platform, and we will just keep building. Again, our goal, one of our key goals, is to build the kind of thing that is going to be used, right? So that means when you say, I don't like this part, it feels clunky, we take that very seriously, and really want to make this the kind of platform that feels natural, simple, elegant, and useful to you. That's all I got. Thank you, guys.
Awesome. Thanks for that, Matt. It's really great to go into that kind of detail. I think it's really helpful for folks. I will make sure to post those slides for people who want to take a deeper look later. If you have questions, as Butcher mentioned, we're available to answer them in the Helm channel in the Kubernetes Slack or the Deis community Slack or on GitHub. Before I wrap up, if anyone has any questions they want to ask about anything we talked about, now is the time. You can post them in chat or just speak up. Some final words as we wait for some questions to pour in. At the end of the day, Helm is the tool that we use to manage everything in Deis, and that's going to be the case going forward. It really is the canonical tool for doing manifest management. It's going to be critical not just for us, but for the entire Kubernetes community. And I think we are, it's an understatement to say we're really, really happy with the new direction Helm's taking, and from what we can tell from the feedback, a lot of other folks are too. So, looking to the future, I personally look forward to seeing support for things like in-place upgrades and upgrade orchestration, which are actually really, really difficult problems. But thanks to the new architecture and the new approach that Butcher outlined for Helm, these are problems that we can solve, in the context of new Helm. So really, really great stuff. Let's see if we got any questions here. Brief compare contrast of Helm versus Kubespray KPM. Butcher, you want to take that question?
Yep. I get it. we've been talking to Antoine quite a bit to try and suss out exactly what he's building. Some of the differences between the platform are fairly superficial, like he's doing Python, we're doing Go. The huge difference is we've now committed to doing in-cluster based management. And last I talked to him, he was committing to doing only client-side management. We are using different template formats. I don't know what the status of kubespray.io is right now, but he had been talking about adding chart support to that. He's changing very quickly as he can do, and so are we. So week to week, our features lineup is shifting like this. I think we're largely both heading in similar directions and saying, all right, we're going to commit to chart repos and not building things straight out of GitHub. We're committing to strong Semver releases. We're committing to reproducibility of the build. So in that way, we're both converging on a similar set of ideas. I'm kind of curious to see how things will go between the two of us. I like the idea that there's someone else putting a decent amount of pressure on us to stay true to our goals, right? If we say we're going to be simple and easy to use and stuff like that, and we get complicated, having somebody else out there say, I'm simpler, is a good way to get us to say, what did we do wrong? We're going to engineer back toward that. So I'm happy to see him around in the community, and we've talked to him. At least one of us talks on our 4-person team. At least one of us is talking to him every week. So it's been pretty good. There are a couple other Kubernetes package managers that surface here and there occasionally, and we have been trying to keep a good relationship with them too, and just kind of keep all the channels open, because at the end of the day, what we're interested in isn't winning some kind of race, but in producing a tool that's actually solving people's problems. So that's all I got.
Great. Any other final questions? All right. Well, that's it for today. We'll see you all next month, same time, same place. Take care.